All right, so let's go through the answers. And I just want to point out how to set this up for a moment. So when we take a look at, I checked most of yours. What was the answer to letter A?
0.
That has no significant digits, incidentally. Yeah. 0.0, I got 3. 0.000? Yeah. How about letter B? Yeah, 0.4772 is what I got. Yeah. Letter C, I got 3.00. Now let's just talk about this one here, all you 2.9996 or whatever you got. I don't know. So let's think about this one for letter C. For letter C, and I'm going to recommend, and I mentioned this to you guys as well, especially as we move forward, it may help to do an ICE table, not for an equilibrium, but to see limiting and excess. So for letter C, this is the one, this was the 49.9 milliliters of base, right? Yeah. Okay. So if I do an ICE table for this, of HCl and sodium hydroxide making water and the salt. I'm going to just do one in moles here. And so originally I have 0.05000 moles of HCl. Where did that come from? 1 molar, 50 milliliters. And I have 0.04990 moles of NaOH. We all good with that? So I can look at that and see, hey, I can see sodium hydroxide is limiting. I have less of it. That means I'm going to run out of NaOH in the end. And so I'm going to lose all of this. So my HCl that's left over is 0.00010 moles. See that? How many sig figs does that have? 2. Now, when I have to compute, so the only thing that's left then that's going to impact my pH is this HCl, but I need to get it back into molarity. And so the concentration of the HCl, which of course is the same as the concentration of the H+, is going to be 0.00010 moles over what? Yeah, 0.09990 liters. Because it's the 50 milliliters plus the 49.9 milliliters together. And that gives me my concentration, which really, when I round it to 2 significant figures, is 0.0010 molar. And so if I take the negative log of that, my pH is 3.00. Because those of you who had 4 significant figures, I just wasn't sure where that came from. Unless you did it a totally different way. But anyway, okay. Letter D. This was when we added 50 milliliters of acid and 50 milliliters of base. What's the pH? 7. We'll have to at least give it some sig figs. Where does that number come from? I mean, yeah, you can look at it and go, yeah, sodium chloride's a neutral salt, so of course it's 7. But mathematically, where does that number come from? Matt?
The H+ from the water.
Yeah, it's the H+ from the water. Because now really the only thing that's in there at that point is just going to be the water aspect of it, which of course ionizes to some degree. So that's where mathematically that comes from. All right, letter E. What'd you get? 11. And we should have some significant figures associated with that. So 11.00. And as we look at this one for letter E, you know, I would encourage you to continue looking at using this mole table, because with letter E, we have 0.05010 moles of sodium hydroxide here, which means that now the HCl is limiting. So we end up with no HCl, and we lose, because this is a 1:1:1 ratio, and so we're left with 0.00010 moles of sodium hydroxide. Divide that by the volume, And I would just take the POH and subtract it from 14. So, in this case, it's, 0.00010 moles divided by the new volume, which is 0.10010 liters. And so that's 0.0010 molar. But that's the OH minus concentration. So if you take the negative log of that, that's the POH, which is 3. Subtract it from 14, you get 11. Right? Good. And then not E again, letter F. I got, what did I get? 13.523. What'd you get? Something like that, hopefully. And this one, same thing, except now we're going to have an even higher concentration of sodium hydroxide. And because it's a higher number of moles of this, we actually end up getting an additional significant figure there. We're not going to be limited to just the 2. That's why we end up with actually another digit here. So, we doing all right on that? Yeah? Okay, so here's what I want us to think about now. This was a strong acid, strong base titration. Now, we need to do a weak acid, strong base titration. And the difference with a weak acid, strong base titration, as I alluded to yesterday when we talked about the reactions, is that we have a salt in there that is also going to impact the pH. In this case, we didn't, because sodium chloride was a neutral salt. But in the case of a weak acid, strong base, the salt does impact it. So let me pull this up for you. You might want to copy this down, but don't copy it down yet. I want to make a couple points. All right, as you look at this, it's the same exact problem as yesterday's, except instead of being HCl, it's acetic acid, which I'm just calling it HAC here. It's not actinium. It's just so we don't have to write out C2H3O2 every time. So it's just a way to abbreviate it. So same thing, except we have acetic acid in the flask, same concentrations, same amounts of the NaOH that are being added. Here's the difference. You're going to probably want to do a moles table like I just showed you to see who's limiting and who's excess. It really helps. And you got to get it back into molarities because now you're going to have an equilibrium associated with each one. And you're going to need to think about, is it a Ka? Am I writing an acid breaking down or a Kb? So the first one's going to be pretty simple. You just have the acetic acid. I'm giving you the Ka for that. So we're going to think about 4 steps quite a bit here. Okay? But in the second one, limiting an excess reactant problem first, change them into moles. Makes it easiest. And then think about what equilibrium is going to be established and what's in there that I need to plug into my ice table. So what I'm going to do is I'm going to give you some time to get started and try to get through A and B and maybe C, and then we're going to stop and we're going to actually go through A and B together to make sure you're on the right track. Okay? All right, so copy this down, talk to your partners, try to work through, get through A, B, and C until just keep going until I stop you, and then we're going to pause and go through A and B together. That'll get you going. Looking at that. So we're gonna go through A and B, and then you guys keep working on this. So let me unfreeze my screen here so that you can see what's going on. Oops, wrong thing. There we go. Okay, here's A. A should have been more straightforward because there was only one acid in there, which honestly did not give you fits last chapter. It's only starting to now. Okay, so with part A, I wrote down the number of moles, but that's not really going to be important in this particular one because there's only one thing in part A, and it's that acetic acid. So that's the only thing in there that's going to be able to control the pH. So I just did a mice table here. I know my concentration of the acetic acid. I lose some, I gain some. I've got my expression, I can plug in my numbers, solve for X, which is my hydrogen ion concentration. And then from there, I can find my pH. Did a number of you guys get that? Did you get that? Okay. All right, now part B. as we get into part B, now we have to consider the fact that there are two things happening. One, there is an acid-base reaction that goes to completion. It's a limiting and excess reactant problem. It's important to get that finished so you see what's left after that reaction. And then there's an equilibrium. So as I do this, this first part here, I'm showing the moles because it makes it easiest to show it. I eliminated the sodium here, only for the sake of making it simpler, and because sodium is a spectator ion, it's not going to play a role here. So I have 0.0500 moles of acetic acid and 0.0250 moles of hydroxide. So when I look at that, I can see that the sodium hydroxide, of course, is limiting, so I end up with 0. That tells me my change here. So I'm left with some moles of acetic acid. At the same time, I'm also gaining some acetate ion. So in the end, there are actually two things that are going to influence my pH. And that's going to be the fact that I have both acetic acid and the acetate ion in there. And so as I look at this, both of those are going to be important to consider when I do the equilibrium. Both the acetic acid and the acetate ion, because that's a non-neutral salt. Okay? All right, so that being said, now I need to establish an equilibrium reaction that contains both acetic acid and the acetate ion. What is an equilibrium reaction that would contain both of those things? Can you think of one? The what? The dissociation of? The dissociation of HAC, right? I could have HAC breaking up into H plus and the acetate ion. Which kind of K would I use with that? Ka. Or, and I like that one, that's the one I would go with. But there's other possibilities. What's another possibility? Another equilibrium reaction that contains HAC and AC minus. What would the opposite way be? Careful. John?
It would be AC minus plus H2O yields OH minus plus HAC.
Yeah, you could do AC minus plus H2O yields HAC and OH minus. What K would you use there? KB. Okay, so you can mathematically, it doesn't matter. I would go with the acetic acid myself just because that's probably going to have a bigger impact. And so as I look at this, here I'm writing one for the dissociation of acetic acid. The reason it's important is because now I need to plug in those values into my initial part. And remember, I was mentioning this to Brian just a moment ago, this is the part where it's really easy to forget to put it back into molarity. When we do an equilibrium ice table, you cannot plug it into the Ka if it's in moles. You've got to get it back into molarity. So I've taken the moles of acetic acid and dividing it by my total volume, which is now the 75 milliliters, 50 plus 25. Same thing with the acetic acid. And I'm, plugging in, I'm accounting for that volume. This is what I started with divided by my 75 milliliters. That ends up being 0.333 when we divided it. And then I lose some, I gain some, et cetera, and I can plug it into my Ka now. And then from there, X is my hydrogen ion concentration, and so I can get my pH. So as you work through the other ones, as you work through C, for example, we got to do the neutralization, see what's left, find an equilibrium reaction that contains the things that are important, and use the appropriate Ka or Kb. So hopefully that'll at least get you moving in the right direction if that was giving you fits. Yes? Keep going. Go, go, go.